Alrighty, ready to get going? Cool. All right, so there's only a few of you here today. So how many of you guys are iOS developers now? A few of you. Are other of you curious? Do Android maybe? No. Web development? Something else in the back end? Yeah. Anybody, are you guys in the back familiar with Core Data at all? Just kind of curious. Some iOS thing? All right, so that's cool. Just bi-curious about iOS. It's good. It's all right. We take all comers. So yeah, I just wanted to come here and talk about Core Data. Core Data, if you're not aware, we'll go over it a little bit, is Apple's solution for persisting data to disk and various other places. But first, a little bit about me. I do a podcast. You might have seen some of the logos and cards out in front. I tossed a few out there. But if you want to hear a lot about iOS development in general, I talk to various iOS developers at places that I meet, that I go. And I've been to a lot of places. I just got done with my European tour for this year. So I talk to people all over the world, talk about all the things that they do with iOS. So it's a good resource for a lot of, just to kind of see what's going on in the community. So there's that. So let's talk about data. Specifically, well, data is the heart of your app, right? In Apple terms, it actually means it's the core of your app. So a long time ago, when you guys have worked at this, right? This is what you work on now? I'm sure, right? So imagine, all this stuff fits in the palm of your hand these days. It's awesome. But back in the days when computers were first invented, they filled, rooms like this. But first of all, where's the display on this computer? Right? There is no display. It was just all data. This is the way computing used to work. So, there was printouts and there was ways to get information out, but it wasn't what we have today, which is this. This is awesomeness. We have all of the power of that thing in the palm of our hand. Definitely more than what went to the moon and back. But what we have here is we've got a device that it kind of shows us all the things that we need. We need to save data, we need to return data, display it, all that stuff. One of the ways that we do that is with SQLite. SQLite is a pretty common way to store and persist data onto disk. A database, I'm sure you're all familiar with things like maybe an Oracle database, MySQL, Postgres. There's all of that out there. Those are very heavy-duty solutions, and what we have in iOS is something a little bit lighter. It's a single-user experience, and it's when you're running your app, it's generally a single process with multi-threads. So we have different limitations and different things, different ways to store data on iOS. Take a look at this app. Apps are data. I pulled this out just because I wanted to show you, like, even though iOS has nice interface and stuff, what really matters in this app is the data. In this particular case, it's it's a blood pressure monitor with a heart rate deal. But the deal is data is the main. It's why people want to use your app. It's really important, and I'm sure you guys know this. You've probably dealt with a lot of bigger systems. So how do we combine these two? Typically, what we do is do something like an ORM. When we're dealing with iOS apps, we have just general objects. We have, Objective-C is generally an object-oriented language. It's got some other features that are functional, and stuff like that. So we can use this. We want to embrace the paradigm of objects, and an ORM helps us do that. But the general problem with ORMs is they are a leaky abstraction. And it's not to say that core data itself is not leaky. It does have some leaks here or there, but they're different leaks. And the key to understanding how core data is different than your normal ORM is kind of knowing where those leaks are. So for example, the prime example is that in a classic ORM, maybe like an nhibernate or just regular Hibernate for you Java people, is that you can put SQL queries into your code and have those run directly on your database. You can't do that in core data for the primary reason that the underlying store may or may not be a database. All right, so we can serialize things into any particular format we want. We could use MongoDB, or we could use JSON. We could write our own JSON persistence layer. We could do all kinds of crazy stuff. But because we don't expect SQL to be the actual persistent format in core data, we don't have that particular leaky abstraction. So I'll get into some more abstractions and where they leak a little bit later. So what I put this slide in here for, whoa, it went too fast. So what this kind of was telling me is that, or it reminded me about, is that what we usually have when we're writing data objects and ORMs and things is we have two kinds of codes. We have kind of model code or things that are, I would say, is specific to inserting and doing all the CRUD operations, right? Create, read, update, delete. We have all of that boilerplate code that we usually have to deal with. And then we also have the things that are related to these data business objects. And we have that kind of data. And we usually want to put these things together with ORMs. And we can do that with core data as well. And I think, yeah, all right. So core data. Let's get into how we use core data. Or let's just kind of describe kind of the architecture and how you would use it, right? So we start off with this thing called NS Persistent Store. You know, like I said, this is our system-provided base class. So everything that we're going to deal here with is objects. This is objects in an iOS app or a Mac app if you're going that direction. But we have a persistent store, and what this is responsible for is actually doing the persistence and performing and pushing all that data to the persistence mechanism. And I say persistence mechanism in general because it could be an in-memory store, it could be an XML store, a SQLite store, or a binary store. Those are the four defaults that you get with Mac, and with iOS, I believe you get binary, you get in-memory, and you get SQLite. You do not get XML. So anyway, we have this. This is kind of the base. And then we have a persistent store coordinator. So you notice that we have a coordinator. Why would we need a coordinator? Well, it means that we have a coordinator to kind of distribute traffic among our objects. So the coordinator can manage multiple stores. It can also manage multiple contexts and things. So we'll get into that more specifically in a minute. But what we also have here is an NSManaged object model. And now this general object basically describes the structure of your data. If in database terms, this is basically a schema for your app. So this reflects the object model that you're trying to describe in your application. The next object is the NSManaged ObjectContext. Now this is, I'm not sure if there's an analogy to this in other technologies. The closest thing I could say would be a session object, maybe in a Hibernate kind of world. But it's a little bit more than that, in that it doesn't really connect across the network. It doesn't manage all those network connections because all of these things are within your app. They're just objects in the same thread in the same process, right? So an NSManaged ObjectContext is what you interface through at the top layer to be able to push all your data through to the bottom three objects there. But this is generally referred to as a scratch area or a work area for all the data that you're altering. And the primary use case for this, say you have a list of data that you're displaying on your app, and you want to go and change one. So what you'll do is you'll take that object, create another context basically in the background, or it could be just basically you have another context. So basically another working area. You copy that object to this other working area, the context, make your changes, and if you cancel those changes, you just destroy the context, and you haven't persisted anything, so you've basically backed out and canceled. But if you do save it, it goes down into the store, and then there are ways that we have to deal with to resync all of those changes back to the main context that you had in the first place. So this is a working area thing, and it's very useful once you kind of get the hang of it. It's one of these weird things that you don't see in many other places. So when you're usually working with core data, you usually work with a whole bunch of managed objects, right? So everything is in objects. Managed objects are the way that we want to interact with our data, and that's how we do it. And generally, this context, like I said, has a whole bunch of references to all those objects. So all of those things, we put them together, and we put them together in something called a stack. And it's not really an object in core data. It's just something that we generally use to reference, to call that collection of things that we need in order for core data to work in our iOS apps. So how do we do that? We can go ahead and just fire up our new template guy here, create a name, go through all this stuff. You know, before we used to have this use core data thing. I think this is still there in the templates. You can check that. And you get some default template code. And by default, you get this app delegate guy, and it's got an instance of all those objects as properties on the app delegate. And you have a save context thing here. But you have, you know, those base objects that I told you about, the coordinator, the model, and a context to work with. So this is your primary way of interfacing with it. So we can go over here, and we go into the actual code stuff here. We have a save context method. It kind of does things okay in that down here we've got manage ObjectContext. It's kind of lazily loaded. You know, it follows some of the good paradigms that Ben was talking about in his last session. You know, lazy load is good. But what I don't like about this is that over here in the save context, it says, well, if we can't save, if we don't have change, if we can't save, then go ahead and crash the app. That sounds like a bad idea, especially in your production apps, right? Because users love crashes, right? So, and what I love even more is in the simple template code, if when you go into the coordinator, which is an even more complex kind of deal here, it gives you even more stuff that you need to do in order for this thing to actually be useful. So this template is more or less useless. And again, we look down here, crash the app if the coordinator wasn't set up properly, because I love crashing my apps. So that's kind of sucky. So let's think about working with core data. Just kind of, normally when you create data in core data, by default, you use this. What are we creating here? What type of object? It's kind of weird. We're actually getting, this should actually be a person object, and what we're doing is we have an entity in our model called person. So it's going and instantiating an entity in the data store, a person entity, inside that working context. So it's a lot of weird code, and it's really hard to figure out what we're actually creating with this particular line of code. I had to try to make it big so it kind of wraps with the lines, but otherwise it's still kind of unreadable. How about this collection of code? Even if you don't read Objective-C, you know, it's kind of a lot of code to do what? It's a lot of code to find data in our data store, right? We're looking for a bunch of stuff. And in this case, we're looking for an employee and, I don't know, some other stuff. And then we also have to handle the error down here at the bottom if that doesn't work. You have to do that all the time. That seems like a lot of repetitive work. Facepalm. Nice. Yeah. So let's look at another way of doing this. And this is something that I wrote, which is you know, part of the session here, part of the title. But anyhow, let's look at turning on the way we set up the stack, rather than having all of that boilerplate code attached to our app delegate, which, again, referring to Ben's session previously, you know, we want to take as much code and as much stuff out of that app delegate as possible because it's not where it belongs. You know, the core data stack is not something that one object like that should own. You could potentially have many references and many stacks referring to the exact same store on disk, all having different access. All the threading and the locking mechanism, all that synchronization is synchronized on the persistent store and then the SQLite level down there. So we don't need all of that stuff to be just through our app delegate and basically having a logic bottleneck. So, however, if we do want to initialize it there, this method in particular is synonymous with basically the main method or main function on C. I guess they do it on other platforms, but this is where you generally have your starting point when you launch an app. And we can set up our core data stack here in one line. Now this will go and set up all of those objects as well, and it'll log the errors. It won't crash unless it really needs to. But it'll handle errors and log them out, so at least you know when something is wrong, you will know rather than just abort, right? So at least this can help you with that. So here we are back with our fetch request. Now, to identify the things that are actually useful, the custom elements in this request, let's highlight them in red or whatever that color is, maroon maybe. But we have an employee, we have a little predicate here, we have a first name and a kind of an order, and everything else is repetitive, it's boilerplate. So what we do in MagicalRecord, we move that over into a simple single line of code like this. And we use some of the language features in Objective-C to achieve this. But basically, all of that stuff that was already on that previous slide is in a couple of helper methods that you can access via this single line of code. Now this makes this easier to read, easier to understand, and you can also kind of build on top of this because it builds one operation rather than this sequence of cluster, all these things that are happening that it's just really hard to decipher. So this is nice, and make it a little bit bigger so you can actually read it from the back there. And yeah, it's it's not that difficult to read. You can see what's going on here. I need to find all the employees that match this predicate and sort them by first name ascending. Great, all right? And every parameter or every method, every finder type of method in MagicalRecord follows these two conventions. First, it has this in-context parameter, which is optional. So what we have is that that manage object context is something that you need to do in order to, you need to pass that along in order for a query or anything to work in core data. But what we have instead is kind of a default area or a main context with MagicalRecord. So if you leave this in-context parameter off, it will use the default one that it already has, which is basically the one that you use on the main thread. The other convention that we have is find can be replaced with the word request. So if we need to customize that request, right? So the NSFetch request has a lot of configuration options, and there was no real easy way to fit them all into a bunch of these helper methods. So rather than having all these permutations of these helper methods, I just put the things that you used 90% of the time in the most useful collection of these helper methods, and give you a way to get the request out and say request all with predicate or whatever. Grab that request, modify any 1 or 2 line things that you need to modify, and then basically send it back into the pipeline so that you can execute that request and get all the information out. It will still then go and log any errors and handle any of the problems there for you. So this has a lot of use and conventions built into it. And on top of this, we can we can build on top of these conceptual simplicities with finding by having things like this find or create pattern. If you did that before, it would be a really big, long, it would be a lot of code and pretty complicated. But with this, it makes it pretty easy. You can see what's going on in the code. If find is nil, then create one in the context, and then you set the employee stuff and stuff like that. The other things that I usually do in core data type of code is have find methods or helper methods that are basically related to the data model. In particular, what you can do is not expose these find methods to your APIs within your app. So in this case, if we have an employee, you just say, I want to find all the employees in a particular department. And rather than saying, well, do a fetch inside of your view controllers or such, you just have that line drawn, like you have that model object of an employee, and you have all of the core data stuff behind that object. So if you really do think that you need to replace core data for some reason, you have these lines drawn, and it makes it really easy to do that here. One of the other things that's really awesome in MagicalRecord that I really like is the background saving helpers. So it turns out that threading is hard in general, but people seem to complain about threading in core data, forgetting how hard it is in general. But it turns out that core data supports threading fairly well. You just have to set it up properly. And it turns out that that setup is pretty boilerplate. So what I went and did was created some background methods so that we could just do something very simple conceptually. And that's say I want to save this data on the background and do whatever this data operation is, do it on the background, make sure that all the data gets saved, and once it's saved on the completion block, it gives me a callback that says, hey, this data is now saved, go ahead and reload and update any views or anything on the UI. This completion block is performed on the main thread in UIs. If you're familiar with iOS, you'll know that any operation that you do on any of the UI kit objects is required to be done on the main thread. And so we made that completion block call on the main thread. The other thing here to note is that with this save block, what you have is this local context here, and this is a pre-configured workspace that's temporary for you. So this is created on a background thread. It's configured to use an existing core data stack, and it's also configured to update the other, in particular, the main context that's already existing and already set up on your app, so that when changes are made to the context, which is what we do here, we say we have our item, we get our item, and we want to transfer a copy into that working context. So we have one on the main area, and we will have one on the background thread. So what we do is once we transfer that object to the background context, we can make all of those changes, and then we can save them all in the background. So this block here, the first one, is performed entirely on a background thread. And you can do all these changes and data updates without interrupting the user on the main thread. So that's kind of nice. And we have got that. And this is how you would implement it, and this is how I do implement it. Basically just create a queue, and I think, just create a queue, and just create the context, create a new context, and set stuff up, and then call the block. It's not that hard to do this stuff. It's just now that all this stuff is done in a single place, so that you can, if you use the MagicalRecord APIs, it's fairly, it's nice because I can make changes, I can optimize things, and use a lot, apply a lot of the things I learned about core data in a fairly easy to reuse package. So over the years, core data or MagicalRecord has been out for a number of years now. It's got quite a few followers on GitHub, and there are a few loose ends. First of all, the logging scenario was not very great. I think it was trying to integrate with Cocoa Lumberjack, but it didn't do it very well. So if you're not familiar with Cocoa Lumberjack, it's a really awesome logging framework for Objective-C. It's akin to maybe a Log4j style of logging, where you have various logging levels and various loggers that you attach to this framework so that you can output it to different places. So that's a really nice framework, and I was trying to use that, but it didn't do it so well. The other thing was the default context was attached to this NSManaged object. Actually, it should be context here. It was attached to this object as a static object that just kind of lived throughout the lifetime of your app, and you just have this class method as a way to conveniently access the method, or the default context. And there were other things like the default model and the default store coordinator. Those objects were basically global objects, and that didn't sit well, and it wasn't compatible with other things, such as if you're using NSManaged Object Document or UI Managed Object Document, two APIs that require individual objects for them to be used, individual instances of core data objects. So that entire stack needed to be recreated in those particular APIs, and MagicalRecord wasn't very compatible with those. This method has also caused me a lot of problems. This was one of one piece of code that was submitted by a user of MagicalRecord. What this thing did was it will check your current thread. So if you look at NSThread, you can get the current thread, and then you can also have access to something called the thread dictionary. And you can store basically thread local variables into the thread dictionary. So what we did there, or what this method did, was grab the thread dictionary, see if it has something called a context in there, or we have a uniqueified name so that we can identify what we're after. And if it wasn't there, we create it and then give it back to the thread. And that way we don't have to create manage object context for every new thread. Now that worked fine in thread isolation mode, and it also worked fine in a world before GCD came around. Now, if you're not familiar with Grand Central Dispatch or GCD, oversimplifying that technology is basically it's a thread manager, a thread pooling manager for you for iOS. And what that also, the implication for that is that queue on GCD does not have a one-to-one correspondence to threads. So that means that you could have a queue use multiple threads, or one queue or multiple queues use the same thread. It's just not a one-to-one correspondence. So 99 times out of 100, this method will work. But that one time it'll crash. And anytime you get a crash like that, it kind of randomly happens and every other piece of code is logically sound and has been tested, it's a threading problem. And this has caused a lot of threading problems over the years with people trying to use it on GCD and such. So this method is causing me problems, and I get a lot of support requests for this, and my goal is to not have to support this because I've got a lot of other stuff to do. And again, we're talking about NSNUI, Managed Object Document. So yes, we had some problems, but hey, we fixed them. Yay! So anyhow, one of the things that I've wanted to do, and I got feedback from this early on a long time ago when I first released MagicalRecord, was to make it a static library, and I couldn't figure out why. It's just like, just include it in your code. But I've kind of come around. What's nice about a static library for me is that it allows me to release discrete versions as far as just a static binary that you can include in your apps. So it will be available as a static library, and I will be publishing discrete, concrete versions 3.0, 3.1, etc. As we go further. But that's something that you can just drop into your app, your project, and link it to that and kind of get going that way. The other thing that you would probably need to do is you would need to include the proper header search paths, because even though you have the symbols, if you don't have the headers, you can't compile because the linker doesn't know that, or the compiler just doesn't know that you have those things defined somewhere else. So there's that. The other thing that I've done is, I use it here generally in sub-projects here. So the way that I do it, since I don't use CocoaPods or the other ways of managing frameworks, what I'll do generally is I'll have my application, and I'll create a vendor folder, and I'll have a sub-project here. And what I can do then is grab the library and just drop it into the linker steps of the main project, so the top level project. So it's really nice. It's really easy to see the dependencies, and everything is built just as you'd expect. So it's pretty nice. You might also notice that I have a .framework thing. So I have a framework thing for Mac versions as well. So that's kind of nice. I like that. And again, I use it down here, and I just copied into this guy, the libMagicalRecord. Got a couple other magical libraries there. So shorthand support. This one's going to go away. I don't know if you've ever used. So this was one of those things. So when I was first learning how to do write Objective-C and Cocoa stuff, I discovered categories and eventually figured out how to effectively use categories, which is in the original set of MagicalRecord functions. All it was just a collection of category methods on NSManaged Object, I believe, and then added a few and eventually built stuff around it. But the thing was that those category methods did not have a prefix. So that meant that anytime you add a category method on a system object like NSManaged Object, or etc., all those core data objects, anytime you add a category method, you run the risk of overriding something that Apple provides you, right? Because if you have two methods that have the same name, the same selector, it's undefined which one wins. Could be that yours loses out. Could be that Apple's wins. The problem is that if you override some of Apple's code using a category, you're hosed. So the community solution for that is to prefix your category methods with something. And so now we've been, I had converted everything to use MR underscore as the prefix, MagicalRecord underscore. So that fixes that problem. But at the time, I really liked just the way that the syntax flowed without the prefix. So I was like, well, there's got to be a way to have an option to remove this if I don't want to. I want to give people the option, the flexibility. And I came up with a really nice, clever way to be able to turn it on and off with a compiler definition. It was just an option, and it would do some runtime trickery, and it was pretty efficient. The problem is when it comes down to the noobs who don't know how to fix that stuff, it just caused more headaches for me. I've ultimately decided that the shorthand support is a really fun trick. It was a great exercise to learn how the runtime works, but ultimately it's not effective in helping me write this library. So I'm going to remove that. I plan to re-release kind of maybe a packaged up way to do the shorthand stuff separately, so that if you want to go and do that, you can just download a different project and apply that. But otherwise, yeah, it's going to go away. So make sure you prefix all of your category methods when you're using this one or any other library with category methods. I added some helper names. So I found that when I was debugging Magical Record and core data problems, it helped to basically label context, manage object context, with some kind of label that was useful for me. Where, like, basically, it's like just a little commit message on the command line. So like when it crashed, or when it's something logged and it said, well, there was no changes in this context, so I'm not saving. Well, what was I trying to save? Well, I can put that in a basically little working name area. And because you can create context basically at will, and I recommend that you create context like crazy because they're so lightweight, you can just now label them, and Magical Record will dump that label on the command line. So at least you can kind of keep track and see what things are going on. So that's just kind of a helper thing, and there are default names in there for certain contexts, such as the main context or the saving context or something like that. So we've got some names, and it's been a useful debugging tool. There's also a method in there about observing a context. So remember when I said that we had to have, when we work on the background thread, we create our context in the background thread, and we have to tell the other context, hey, the background stuff is done. But we do that through a notification, and there was a lot of boilerplate stuff because you have to get the notification, and then you have to perform some code to merge, and it was all boilerplate. It's really all the same thing, when all we're trying to do conceptually, hey, main context, watch this background context, and it just sets it up. And there's also a stop observing background context kind of thing. So it's just helper things like that. Parent chain. So in iOS 5, we got a new API that lets us kind of set up parent-child relationships between managed object context. So like I said, so in the old way of doing things, we had a background and a background context and a foreground context. In order to sync them, that whole observation thing, what it had to do was this background context had to save to disk, and then it would notify the main context, and the main context would say, oh, okay, I've got data. It would pull it up from disk, right? So that can be slow. There's a lot of I/O involved, right? You're pushing it down to disk and pulling it up from disk. It's the order of magnitude slower. Right? So now instead of just going all the way down to disk, we set a relationship. It says, hey, I've got a child context and a parent context. What we do is we save the child. All those changes go directly in memory to the parent, and there is no disk I/O involved. So that's significantly faster. So what we have is we can set nested levels of chains like that. So we just have a little thing to walk the chain and debug that thing. These are just little helper things. I wrote this method because in iOS 7 now, journaling, there's a new saving mode. So SQLite has basically something called write-ahead logging. It's significantly faster to write stuff to the database, and stuff like that. It's highly performant, highly, whatever their reasons were, there are good reasons for doing this by default. And it turns out that when you copy just the .SQLite file, you don't get everything. There's stuff in the WAL file and the SHM file, the shared memory file. There is stuff in there that you need to copy, and basically this just is a stupid helper method, copies all the files and making sure that we copy, when we're copying a store, we're copying the entire thing. So there's just a lot of helper things. Logging, I fixed logging, so that's awesome. So logging is now a two-phase step in Magical Record. There is still the old compiler way to enable logging. This will, if you turn it off, it will strip all the log messages out of Magical Record. So it won't log at all. But if you enable logging, if you keep it on via the compiler, which it is on by default, if you keep it on, you actually now have a runtime setting, and you have something called a log level. So basically, I have info, verbose, error, warning logs just for Magical Record, and it all uses Cocoa Lumberjack. And if you don't have Cocoa Lumberjack, it'll just dump it all down to the console. So logging is a hell of a lot better in Magical Record. And if you need to learn how to implement this for your own app, maybe, because what I've done is actually taken the template that I use for Magical Record as far as logging and all the prefix stuff and the the logging header file that I use. I use that for my own apps now because it's very useful and flexible. And all I do is I change the prefix. So I'll do a global search and replace on the prefix. So this might be something that you want to look into as far as a source. And I think if you look at MagicalRecord logging.h, that will have all of the preprocessor definitions that will help you out there. Errors were terrible in Core Data. Even if you were lucky enough to get an error in the first place, you had to decipher all those stupid error codes, right? So, you know, I took the time, it took me a couple of hours to research what all these stupid errors were. And this is just one category of the errors. And map the code to something that's a little bit more descriptive. So before, if you just dumped this thing out, you know, it would get a 1550 or 1560, right? You get some random error code. Now you can kind of see on the console what the heck's going on. What it'll also do is part of the error handling now is it'll detect a 1560, which is a multiple validation error, and log all the properties that are actually incorrect with why they're incorrect based on the codes that we get back. So you actually can see what the hell's wrong with your data, with your state, with the saving, with the store, with anything that happens in Core Data that's broken. You can actually see what's going on in the log. So I think that's pretty helpful. It's helped me a couple of times. So yeah, that's useful. The biggest thing that's in MagicalRecord 3.0 now, though, is stacks. So we had all of those objects, all these things down here at the bottom. The context, the coordinator, the model, and the store. And that is commonly referred to as a stack, but there is no stack object in Core Data itself. In the framework that you get from Apple, there is no stack. So I made one. And it's really not that hard. I think a lot of people do this. They'll make their Core Data Manager thing because Manager is official. And what they'll do is they'll just have one instance of that. So I kind of did that. So I started there. And you know, that's fine. So you know, we can look at this guy. So this is what makes up a stack. But the awesome thing about the stack is what I did is I assigned not only the responsibility of setting up the stack and building up all those objects, I assigned the responsibility of vending new managed object contexts. So this is key in the way that background operations work in Core Data. What you need to do to work in a multi-threaded scenario in Core Data is you just need to have a new context set up for you by default. You need to use these new contexts and work in those contexts and let them go away. You just need all these things all the time. So those are its two responsibilities. One, build the stack when you ask for it, and two, vend these new contexts. Turns out that's all you need to make some really useful stuff with the stack. So there's one more fancy animation there for you. So before, remember I had the default context and default coordinators and stuff. Now you just have a default stack, and then you can get the context coordinator model and whatever default store is on that stack. Just go for the default stack instead. All right, so that's got its own space. It lives in its own place. It doesn't mean that you can't make multiple stacks or more. Core Data objects are generally lightweight anyway, but you know, we can just deal with it at one time. Singletons, let's not do those, please. This is not a singleton. Singletons I think, are really just misused. There are proper uses for a singleton object, basically something that lives longer. But basically, if you're accessing, you know, some object space, default instance or shared instance or whatever in your code, that's doing it wrong. You really just want to assign a reference. You basically use it as a property. So pass it in as a dependency and use it locally like you would use any other instance variable or property. Just use it that way. And you know, I try to be able, I distinguish the default stack from singletons in the classic sense of the word, because you really have no way to destroy a singleton. You can't destroy the NS file manager default manager, right? You can't destroy that guy. There's no way. You can't dealloc that guy. Well, I guess you could. You'd probably crash something too, because you don't know. It's undefined, right? But with a default stack, with any of those things, you can just swap out the stack to be whatever you want to be the default at any time. It's not restricted at all. Subtle difference, but you know, I like to make that distinction, I guess. And again, to vend a new context, just get a confinement context. So it turns out when you are working, it turns out the old way of saving data in Core Data was with just a regular old managed object context in threaded isolation mode. Those are now referred to as confinement context. They are non-threaded, non-queued. They're just classical. It's really the old way that core data used to work. And what you can do, though, however, is that you can set a confinement context as the child of a background queue context. So what we can do is we can, this is how we want to save. We want to save all of our data just on the confinement context because it doesn't do any queuing or threading or locking or slowing things down. It doesn't have to do any coordination. It will operate on whatever queue you need to and then coordinate those changes via that in-memory data saving process that's built in now. And then after that, it'll operate on a background thread or wherever you specified as that context to save at. So this is what we want to use to grab our context. And when we set up stuff, it's really the same deal. I've changed the method names a little bit, the setup a little bit. So we have setup SQLite stack. So it's a little bit more descriptive. Before it was like setup core data stack or something like that. I tried to take the word core data out of it just because it just seemed redundant. But it's a little bit more descriptive. We have SQLite stack. We also get a stack object from this method. So we can save this off somewhere if we want to do it in our app delegate, if we want to pass it to a view controller, if we want to pass it to something that is using a UI managed document or such, we can just pass it along. So we have a reference to this. And this will set this, what this method does and all of its variants, it will create an instance of a particular stack and it will set it as a default stack and then load it up. So it'll go ahead and initialize it right there. So we can do all that stuff there. And again, here's some API changes. We just changed that thing up here at the top rather than, I think it was I think it was just MagicalRecord, save, whatever. Now it's just grab the default stack. So now the default stack has some extra, just some extra helper methods so that, if you want to do the same thing that you did before, you just do it against the stack rather than they're just this kind of global class object. The cool thing, once you kind of have this idea of a stack, you notice how we set up SQLite stacks. We can have other kinds of stacks too. So this is kind of the newer way of doing things. So we have, our core data stack model here. We've got a store coordinator that knows about the model, and we have the context that knows how to talk to the coordinator. And then we have our background context. So one of these saves to the background, and the other one saves basically using the main thread. And we just have it so that it goes in, and the background one is what vends our context, where we vend our context from, or our confinement context from. So we set that one up as a child as well from that context. So this one would be maybe the background. We set the child as this one having a child, and we do our changes there, and it saves on the background that way so that we still have background saving, but we still also have it under the covers set up so that the background context can update the changes to the main context or the one that's on the main thread. So over here we've got another kind of where we regular starting point. And another setup that we could have are multiple stores, right? Core data does not, it's extremely flexible. It does a lot of things. There hasn't been like a data scenario that I have not been able to solve with core data yet, at least. So one of those scenarios is having multiple stores attached to a single coordinator. It turns out that you can have multiple objects coming from multiple different stores or wherever. As long as all of these stores are attached to this coordinator, you can just fetch, and core data will find the right thing for you. It will do all that work via the coordinator. So you don't have to do a lot of work otherwise. And if you fetch an object out and then make changes and then save it, just via this single interface, this single context, it'll still assign it to the proper store. That reference is already in the managed object. Which store it goes to is already there, so the coordinator knows where to put it. So this is also supported. Let's see, I think there's one more here. So there's also, I think there was a post, maybe, what years? Like 4 years ago, actually. I remember this thing. It was by LinkedIn. They said, they did one of the Stanford 193 course. They did a guest lecture and talked about their LinkedIn app implementation. And in that video, they said that the only way that they were able to get true data persistence concurrency was to have two custom stacks. One was completely in the background, and the other one was the main thread stack. So basically, one was a read stack and the other was a write stack. All right, so we can support this in Magical Record now fairly simply. But the idea with this is that we have two contexts, two coordinators. They share the same model, and this should be actually the same store. But the idea is one writes and one reads, and the locking is handled. The coordination for access of the SQLite files handled at the lower database level and not even at any object levels. So we can eliminate all that file locking and all that object locking from any of that from the code. So that's kind of nice. So the thing is that, so we've got our sample code here, but the idea is that these Magical Record stacks, and you notice that we don't do we only use the Magical Record top level class API. What these stacks are an object-oriented hierarchy of all these different stack implementations. All right, so this uses some fairly simplistic object-oriented design principles. We have a pretty simple base class as basically our interface for every stack, but all of these implementations are performed or are written in different subclasses, so that we have a SQLite stack, and underneath a SQLite stack we have one that has the two coordinator, two context stack. We have one that is an iCloud stack. There's an iCloud stack. There's also an in-memory stack, and we just have different classes of these things, and they all conform to that parent level API. So that means that all your code ever knows is that you're using Magical Record and you're saving data onto a stack, and the stack conforms to the API, so you can swap out the implementation details on startup or whenever. You just swap out the stack and off it goes. So that is really the power of the way these stacks work now. And I've done some performance testing on some of the stacks as far as just getting things to work sometimes, and swapping it out just changes the way it works. And if that's what you need to do, then you need to do that. But it's really easy to swap out what it is as far as setting up. You can set up with an in-memory store here, or you have the auto-migrating stack here. We have all these options. You can set it up with a particular store name, and this has a whole bunch of ways to generate a store name and figure out the URL, where to put the store, all that stuff just based on a string that you want to name the actual file store. To do, there's still a lot of to dos. One of them was iCloud, and I think I've actually fixed that recently. This is all open source on GitHub. Yeah, it's pretty popular. Turns out, this is maybe a couple hours ago, 4,500 stars, which is pretty crazy. I think I was happy when it got to 100 way back in the day. So that's it's a pretty good repo. Project changes to Magical Record though. I have not been the best open source steward of this particular project. I think it was the only one that I've ever done that actually got popular. So I was doing a lot of learning along the way, and there's a lot of big messes made. So yeah, general support, the way that we're going to do support now. We are going to use Stack Overflow a lot. And if you tag questions with Magical Record, I get emails on these every day. And I am surprised at some of these questions. They basically reflect what Joel was saying this morning, which is pretty sad. But the thing is that we got a lot of issues that were basically Stack Overflow questions. And also people would cross-post. They'll write up a GitHub issue, and then they'll also write up a Stack Overflow question. I would get these things twice. So basically the rule is go to Stack Overflow first for general usage questions. If you've then found a bug, then log an issue, which I think is what makes sense. So yeah, pull requests, I think we're going to do everything on the develop branch, and I think we want to encourage unit testing because I like my code to work and not crash. Tony Arnold, this dude is awesome. He's the guy that's been doing a lot of the laid work. It's sad that he recently had a parody account, Tony Arnold's Rage, because he really gets on people's ass when they don't do things right. So he's been my right-hand man managing this thing. It's been really awesome to have his help. And so yeah, that's Magical Record 3.0, new and improved. So have at it. You can grab it. You can just head on over to MagicalRecord.com. We've got the domain. We have a lot. We've got some improved documentation coming as well, so that's helpful. And a lot of apps use this. So yeah, thanks for listening, and hopefully Magical Record helps you with all of your core data problems. Thanks. We have questions. Any questions at all?
So a fairly obvious one.
I think they want to record the questions.
So it sounds like from the sort of description you gave, it's not going to be backwards compatible with those of us who kind of have 2 in there and we want to put 3 in.
Right. From a code perspective, we knew that going. So for one, we made the conscious decision to make it not backwards compatible because of, well, for one, it's a major release, so we're just going to bite the bullet now and, take that hit now. But we're hoping to not, introduce as few code changes as possible. We've also gone through and marked a lot of the header methods as what we're going to get rid of as deprecated. So any of the shorthand methods that you've used before, we've actually put that in one of the last 2.x revisions. We've marked all of those as deprecated, so that you'll get messages in your code that, hey, we're moving on from this, but it is not as backwards compatible. Yeah.
And sort of a second question on that is, are you continuing support for the pod in this then? So
yeah. So the CocoaPods thing. Yeah. So Tony Arnold, he does a lot of. He works with CocoaPods. I don't. So he's been fixing that. And recently we had a CocoaPod issue, and he was the one who was fixing that. So I guess that's bad for me for not using it, but I guess I'm old school now at this point. So yeah. Any others? All right. Well, it's time for beers, I guess. Excellent.